This is Miss Monson from Shady Brook, and this video is about solving a 2-digit times 1-digit multiplication problem, building up to the algorithm. Now, I know parents love the multiplication algorithm and want to teach it to their kids. I get it. I love it too. But remember that we're trying to help your child build a solid foundational understanding of what the algorithm means and why we do it. In the multiplication and division open array video, I went over how to use an open array for this type of multiplication. You might want to review it. This video will focus on the process of moving children towards using the algorithm while supporting them in understanding why the algorithm works. The first step in this process is multiplying tens. Kids love multiplying by 10. They love just adding a 0. So then we move to multiples of 10, 20, 30, 40, etc. We talk about how counting by 20s or 30s is similar to counting by 2s or 3s, but with a 0 at the end. And we learn to multiply something like 50 times 7. We know that 5 times 7 is 35, so 50 times 7 is 350. Our next stop is breaking apart the 2-digit number. So if we have a problem like 36 times 3, we'll solve 30 times 3 and 6 times 3. We'll show this with an array of 36 times 3 that we split into two smaller arrays, 30 times 3 and 6 times 3. 3 times 3 would be 9, so 30 times 3 is 90. 6 times 3 is 18, so one array has 90 and the other has 18. We can add these arrays back together and get a total of 108 for 36 times 3. For more information about arrays and more examples of breaking them apart, watch the multiplication breaking apart an arrays video. We start with the array so that we can see the picture and understand the visual. We usually start with smaller numbers and show all of the squares in the array before moving to larger numbers and open arrays with no squares inside. So we're moving from a concrete visual model to a more abstract model. But it's still a model, an image that kids can hold in their head. Later we'll move to just numbers. Remember, this is not one lesson or 1 week. I give your kids a lot more time and examples than I'm giving you. When we get into straight numbers, we'll start preparing for the algorithm. Usually I like to give them a chance to break apart a problem without using the array. So for 24 times 7, I would break apart 24 into 20 and 4, multiply both of them by 7, and then add the answers. 20 times 7 is 140, 4 times 7 is 28, 140 plus 28 is 168. Now, in 3rd grade, your child is not required to use the multiplication algorithm. So if he's found a strategy that works for him, we'll try and guide him deeper, but we don't want to confuse or overwhelm him by making him learn something he's just not ready for yet. The next step is the expanded algorithm. So let's try that for 73 times 5. For the expanded algorithm, we'll stack the numbers. The order you multiply in doesn't matter for this problem, as long as you remember that that 7 is not worth 7, it's worth 70 when you multiply. So we can start with 3 times 5 or 70 times 5. 3 times 5 is 15, 70 times 5 is 350. Notice that we're keeping both answers separate, just like in our array. Once we've multiplied both digits, we can add them together, just like we added the arrays together. And we'll get an answer of 365. Last, we learn the algorithm. Let's use that for 24 times 4, and I'll show you how it connects to the other ways we learned. We start with 4 times 4, which equals 16. This time, we don't write the 1 with a 6, we carry it because it's a 10. We're not going to need it for a minute because we still need to multiply 2 times 4, or 20 times 4 really. 2 tens times 4 equals 8 tens, or 80. We don't need to do anything with the 0 because there's already a 6 in the ones place. But we have 1 10 we need to add. Now we have 9 tens, or 90. We put a 9 in the tens place, and we're finished. Now, when we reach this point, hopefully your child is also able to connect our earlier models with this algorithm. This is Miss Monson, and this video was all about multiplying 2-digit times 1-digit numbers without using the algorithm.